An 1800 kilogram elevator moves up and down on a cable. Calculate the tension force in the cable for the following cases. The first case is the elevator moves at constant speed upward. Let's start by writing all the information we're given. First, we're given the mass, 1800 kilograms. We're asked to find the tension force in the cable. That would be F sub T. That's our unknown. Next, let's see what the problem says. It says the elevator moves at a constant speed upward. Constant speed means the speed does not change, and therefore acceleration must be equal to 0. I'll add that to my list. Next, we're going to make a free body diagram. We have the car being pulled down by gravity, so that would be mg, our weight, and a tension force pulling the car up. We know that acceleration is equal to 0. And I like to add that to my free body diagram. Let's move on and use Newton's second law. Looking at our diagram in our information, we see that the acceleration is 0. Well, we can put that in for the acceleration now, and that would be 0 times m, which would be equal to 0. Therefore, sigma f is equal to 0. Now, sigma f, we're going to go back to the drawing, and we're going to look at the directions of the forces. Up will be positive, down will be negative. Therefore, the tension force is positive, and the mg will be negative. That will be equal to 0. We need to solve for tension, so let's add mg to each side. If we do that, we're left with tension force equaling m times g. Good. Now what we can do, since we've isolated the tension force, is substitute values into the equation. We know that the mass is 1800 kilograms, and we know the acceleration due to gravity is 9.8 meters per second squared. Calculating that, we find out that the tension force is equal to 17,640 newtons. Okay. Let's go on to part B. Part B says the elevator moves at a constant speed downward. Well, again, constant speed implies that the acceleration is equal to 0. So for part B, nothing has changed. The free body diagram is still tension force up, mg down, and the acceleration will be equal to 0. Therefore, sigma f equals ma, a is equal to 0, sigma f equals 0, and we know that tension force minus mg will be equal to 0, which means tension force will be equal to mg, and that will be the same result we found last time. The tension force will be equal to 17,640 newtons. Let's move on to a more interesting case. In part C, the elevator accelerates upward at a rate of 2.4 meters per second squared. Okay, now we know that the acceleration is 2.4 meters per second squared. Let's add that to our list of information. We know that it's 2.4 meters per second squared. We know the mass is 1800 kilograms, and we're still looking for the tension force in the cable. Okay, let's apply a free body diagram to this problem. We have weight down, that would be m times g, and we have a tension force upwards, ft, and we also should add the direction of the acceleration. It says it's accelerating upward, so let's add that in. Now let's apply Newton's second law. Sigma f equals ma. We know that tension force is up, I will make that positive. We know mg is down, that will be negative. The acceleration is up, so acceleration should be positive as well. So that will be m times positive a, or just ma. Let's solve for ft by adding mg to both sides. Okay, these cross out. We're left with ft is equal to ma plus mg. Now we can substitute values into this. Okay, ft will be equal to 1800 kilograms times an acceleration of 2.4 meters per second squared plus 1800 kilograms times 9.8 meters per second squared. Okay, We calculate that out and we find that 21,960 newtons. So Ft will be equal to 21,960 newtons. Let's move on to part D. Part D says that the elevator is now accelerating downward at the same rate as it was in the last problem. So downward, we're moving at 2.4 meters per second squared for an acceleration. The mass is still the same, and we're still looking for tension force. Here's our free body diagram. Yet again, we have tension force up, we have mg down, and the acceleration this time is downward. Let's apply Newton's second law, sigma F equals ma. We have tension force up, I'll make that positive. Then we have mg downward, that's a negative mg. And the acceleration is pointing downward here, which means the acceleration should be negative. So that would be like saying m times negative a. And I like to rewrite that, ft minus mg equals minus ma, pulling the negative out in front. Let's solve for ft by adding mg to each side. Here we find that ft is equal to mg minus ma. And now we can substitute values into the problem. Ft is equal to 1,800 kilograms times 9.8 meters per second squared minus 1,800 kilograms times 2.4 meters per second squared. And we find that the tension force is equal to 13,320 newtons. There we have it.